Okay, logarithm video part 10. We want to set up the table of variation and graph the function of f of x equal x minus ln x. We did x previous video, we did ln x, now x minus ln x. Okay, first, as usual, x is greater than 0, and this is the domain, right? So the domain of the function f is from 0, open at 0 to plus infinity. Okay. Second, we need to find the limit at the end points, right? Limit. So we always do this procedure, huh? Limit of f of x as x approaches 0 plus is equal to limit of x minus ln x as x approaches 0 plus. We just substitute 0 instead of x. We got 0 minus ln 0, which is equal, 0 is 0, minus ln 0 is minus infinity, so the answer is plus infinity. If limit of f of x as x tends to number, which is 0 here, equal infinity, right? Then x equal 0 is vertical asymptote. X equals 0, which is the y-axis. And the limit of f of x as x approaches, limit of f of x as x approaches plus infinity is equal limit of x minus ln x as x approaches minus plus infinity, sorry, which is equal all right, it's infinity minus ln infinity. This means it's infinity minus infinity indeterminate form. So we should change this form. It's equal to limit as x approaches plus infinity. Okay, x minus ln x. The best way to do that is to take x common into 1 minus ln x over x, right? Now, if we substitute infinity, limit of ln x over x as x approaches infinity, you can go back to limits, right? It's going to be 0, and we can do that by L'Hopital rule, right? What left is x times 1, which is x times infinity, which is infinity. If limit at infinity is infinity, so possibility of having oblique asymptote, which is y equal ax plus b, we have to go and find a first. A is always equal to the limit of f of x over x as x approaches plus infinity here, which is equal to limit. F of x is x minus ln x. We divide by x, so it will be x divided by x, which is 1 minus ln x over x as x approaches plus infinity, and that will be, this will be 0, and what left is 1. If a is constant, we have to go and find b, right? We have to go and find b. What is b? b is equal to the limit of f of x minus ax as x approaches plus infinity, which is equal to the limit of f of x, which is x minus ln x, minus ax, and a is 1, so minus 1x as x approaches plus infinity. X minus x cancel. We substitute infinity. Ln infinity is infinity times minus, it's minus infinity. If b is infinity, if you remember, then y equal ax, and a is 1, right? So 1x is an asymptotic direction. So the curve x parallel, as if it's parallel at infinity to y equal x, and as if it's running away from it, not approaching it. Now the derivative. What is the derivative of f of x? X minus ln x. This is f of x. Derivative of x is 1 minus derivative of ln x is 1 over x. So the answer is x minus 1 over x, taking x common denominator, right? Now, taking f prime equals 0, this means the numerator equals 0. This means that x is equal to 1. X is equal to 1. Substituted in f of x, f of 1 equal, which is y, right? Equal x minus ln x, so 1 minus ln 1. Ln 1 is equal to 0, right? What left is 1. So the vertex, this is y. So the vertex, this is a critical point, right? Maximum or minimum. The vertex is 1, 1. Okay, we found derivative, we found limits, and we found the asymptotes. We deduced the asymptotes. Now we are going to, and we did the derivative. Now after derivative directly, we have to do the table of variation. Table of variation, which is x from 0 to plus infinity, according to our domain, but not at 0. It's not defined at 0. Here f prime of x, and here f of x, right? And do we have a special point? Yes, we have. If x is equal to 1, derivative is 0, and ordinate is equal to 1. That's great. Okay, from 0 to 1, we notice that if we substitute numbers between 0 not equal to 0 to 1 not equal to 1, we can find that the answer is going to be equal to a negative number. It will be a negative number, right? And from 1 exactly and above, it's going to be positive. At 1, it's going to be 0. So it will be down to 1 and then up to, okay, down from where? From minus infinity. Sorry, from plus infinity. From plus infinity, it goes 1 because limit at 0 plus, as if you remember, here we found the limit at 0 plus, and we found it to be plus infinity. So it goes down. So also we can do, without substituting any numbers, we can notice that this will be a negative. And limit as x approaches plus infinity, limit as x approaches plus infinity is plus infinity. And we have y equal x here as asymptotic direction. And here is the vertex, 1 abscissa, 1 ordinate. That's great. If we do that table of variation, this means we draw directly. Let's see if we have a common point between the function, which is y equal x minus ln x, and the asymptotic direction. We have y equal x, right? Let's see if we have points of intersection. Y equal y. If we have point of intersection, we should have it here. We should find it here. We subtract x from both sides. We got minus ln x equals 0. This means that ln x equals 0, right? Which is ln 1. Ln x equal ln 1. This means x is equal to 1. And if x equal to 1, we just found it that y is equal to 1. So the vertex is the point of intersection. The vertex is the point of intersection. We just still need to draw. This is simple. This is simple. Let me draw it here first. I will draw fast so we can use the math drawing. Okay, we have y-axis as we have y-axis, sorry, x equals 0 means y-axis as an asymptote. So this is asymptote, right? We have y equal x, which is the first bisector. If we draw it, it's going to be the first bisector, right? This is y equal x. We have, if abscissa 1, ordinate 1, this point, right? It will be down like this, and asymptotic direction with this, and here asymptote, right? Because let me try to do it fast because time is over. Let's see, graphing. It's x minus, right, ln x. X minus ln x. Let's directly see the graph. Okay, that's it, right? That's it. At 1, 1, this is the point 1 here. If you can see, at 1, 1, 1 abscissa, 1 ordinate. This is the point. They didn't draw the y equal x, which is asymptotic direction, and it goes asymptote with the y-axis to that point, and then it goes parallel, as if it is parallel to the y equal x, as I did draw it here. That's it. See you next video.